All right, in this video, I'm going to go over the descriptive statistic review problems. So, in chapter 1 to chapter 3, we study descriptive statistic. So, descriptive statistic means to study the sample data by summarizing the sample data and then find the mean and standard deviations and variance, things like this. And then to plot the graph of the data so that we can figure out how the data is spread out, and then we want to figure out to better understand the data. Okay, so that was the descriptive statistics. So we learned the histogram and then frequency distributions and pie chart and dot plot and the frequency polygons, and then the sample mean and data, sample mean and standard deviations, a lot of things we learned in chapter 1 through chapter 3. So we're gonna just look at these problems in handout. So we'll see. So first one, the example, the sample data is given. A is in years at inaugurations of the sample consisting of 20 past US presidents. So there are 20 data values in the sample data. So the first question is this: beginning with a lower class limit of 40 and using a class width of 5, and then construct a frequency distribution table. So yeah, there are two ways. You can just, I mean, yeah, we know how to plot the frequency distribution. Let me do by hand, and um, then we'll see, and then I'll tell you how to figure out the numbers in the frequency distribution using calculator. Okay. So by the way, what's the frequency distribution? Frequency distribution is nothing but just a table consisting of two columns. The first column is the class. I mean, a classes range of the data values for each row, and the second column is filled with the number of data values belong to that class. Okay. So let's see. All right, so here I just drew the table like this, and then I told you the frequency distribution consists of two columns, class and frequency. So first one, the problem says that the class limit of 40, lower class limit of 40. So, and then we have to start from 40 in the first class. And then using a class width 5. So class width, what does that mean, class width? This is the number we can get I mean, that class width means that the difference between two consecutive lower class limit is the class width. So 40, and then the next row, the lower class limit minus that 40 must be 5. It means that there should be 45. Okay. And then, so the next going to be 50, right? And then 55, and then 60 and 65. Okay. So we're going to find out the upper class limit for each row. So it should be 44, because the that one can be determined by what, one less than the lower class limit of next row. So 41 less number than 45 is 44 right here. So in the 49, and then 54, and the 59, and then 64, and then this should be 69. Right? Okay. So now then we're gonna count the data values belong to each class. Okay. So you can do by hand. Okay. Or you can use what the calculator, right? So, but let me use a calculator. Okay. So now, um, but either one just fine. Okay, you just manually just find out the data value belong to each class. Okay, but let me use calculator. So open here, and then we go to the stack. Let's see, click here, and then you can see that there are three tab right here, and then we under the edit tab, and then we click the edit. Okay, so now I already entered the data value in column L11. Okay, by the way, normally, I mean, the initially your calculator it has only 6 column, L1 through L6 maybe, but how can you extend the I mean extend the number of columns in your calculator? Then go to the just go to the column name, and then you see that press the, see that, right, the arrow button right here, for example. So for me, I had a 16 columns L6, and then I move to the next column. It will automatically just generate the new, create the new column. Okay, and then you put the name. For me, I have to put L 17, right? So you see right here, L right there. See L, and then 17. By the way, in here, what does that mean? A means is the alphabet, that button, that function is was set. So I have to unset. Okay, and then put 17, that 117. Okay, and then press. You see that the arrow down. Okay, so I just create a new column, L17. By the way, back to L11. Now then you see I already enter all the data value right here, and then now I'm gonna plot the histogram. Okay, so the press, we go to the stack plot right here. You see stack plot. So press second and then one stack plot, and then make sure that all the other plot 2 and 3 are off. Plot 1 is the on only. Okay, enter, and then we just uh, choose that type histogram, and the L11, just leave 1 is frequency. Okay, and then we put press zoom. I told you some calculator, um, including my calculator, when you press zoom, you got this weird, the screen, but it's okay. So we just press second and then stack, go to stack plot. Okay, and then now here we just press zoom. Okay, and then press 9. Okay, so now then that one here, yeah. So this calculator just they generate the histogram, um, but we have to check that if that histogram was generated by the same the parameter, I mean lower class limit of 40 and class width of 5, mentioned in the problems. So to check that, we press window. Okay, then X minute, that means lower class limit should be 40, not 42, so we have to change it. Okay, and then X maximum, when you see that, you don't have to check this, okay, unless the that number is below the maximum data value. Okay, but I'm sure that in that data set given in problems, the maximum data value is 69, so 74, that's fine. And the X scale, that's the X class width, should be 5, not 5.4, so change it. Okay, and then Y minimum, Y maximum, it should be fine. Okay, just leave it. Okay, I mean, so Y maximum must be, yeah, should be enough. Okay, the Y maximum represent the number of data values belong to each class. Okay, so if that was set, if you set this one to 1, that does make sense. Okay, so in using just common sense, when you look at the data set, the number of data value belong to each class must be maybe in general maybe greater than 5 or 6 and 7. So 9.36, that should be enough. Okay, so now we don't press zoom. Okay, you have to press the graph. Okay. Okay, so now then we press trace. Okay, so that we can figure out the lower class limit and the upper class limit for each row, each class. Okay, and then number of data, which is frequency. So you see that here, X minimum 40 and the maximum 45. Okay, so it means the lower class limit is 40, upper class limit is 44, and then is n equals 2, that's a frequency. Okay, so this is 2, so this is 2, and the next one is 2, also 2, and then 7, and then 5, and then 3. Okay, and then excuse me, and this is 1. Okay, So you have to make sure that total number of frequencies must be equal to total data value, total number of data values. But total is 20. I showed that 20. Okay. So now, give me a second. All right. Okay. So we're back to the handout and then see the next question. So draw the frequency histogram. We just got it, right? And using calculator, the relative frequency polygon. So to plot the relative frequency polygon, we need to figure out relative frequency, okay? So let's see here. The relative frequency, let's say LEL, frequency. What's the relative frequency? The relative frequency means that the number of data value, frequency divided by total number of data value, which is 2 over 20. Okay, maybe just you can depending on problems. Maybe problems ask you to find the relative frequency as percent. Then you have to multiply 100. Okay, but just leave it, and then this is 2 over 20, and then 7 over 20, and then 5 over 20. 3 over 20, and then 1 over 20, and then 20, not total, total just, okay. So total just, in this case, total must be 1, right? So now what does that mean, 1? So the sum of all these relative frequency must be equal to 1, right? All right, so now let's plot the frequency polygon. To plot the frequency polygon, so we just draw the two axes. Okay, first, the horizontal axis represent the middle class, or you can say class. Okay, so we're gonna figure out the middle class, which is the middle value between the lower class limit and the upper class limit. Okay, so for the first class, the middle class value, which is middle class must be 42, right? So here's 42. Okay, and then next one is 47, right? And then 52, and 57, and then 60, 62, right? And then 67. Okay, and then the vertical, the axis represent relative frequency. Okay, so this the first one, 2 over 20 is 0.1, right? So 0.1. Let me say just let's say here's a 0.2. Okay, 0.4, then 0.6, 0.8. Okay, I think that's enough. So on the first class, the relative frequency is 0.1, so maybe right here. Okay, we just plot the dot for each class to represent relative frequency. Okay, versus the middle class. So 47, that's the 0.12. Okay, and then 7 over 20, that's the 0.35. Okay, so maybe right here. Okay, and then the 0.25, maybe right here. Okay, and then that's the 0.15, maybe right here. And then this is point 0.05, right? So maybe right here. Okay, so we just connect all the dot like this. Okay, so now you can see that it's not quite accurate. Right? This graph is not quite accurate. So let me let me plot the frequency distribution, relative frequency polygon using calculator. So there is a way. So now you go to the calculator, and then first we're gonna go to the edit. Okay, press stack, and then go to edit, and then we enter the mid class for each class. Okay, see 42, and then you see the 47 and 52, and then 57, 62, 67, and then I enter the frequency, relative frequency for okay, in the other column. Okay, so I just enter the middle class values in column L13, and then I enter the frequency, relative frequency, in the column named L2, L12. Sorry, L12. And then now what we're gonna do? We go to the stack plot, press second, the y equals, press the button y equals. But that's the way to go to stack plot, right? And then we go to the plot one, and then we choose the it's the second type. That's the relative frequency polygon, or any frequency polygon. Okay. So now in the here, and then you see we have to enter the two the data data set. Okay. So X list, that was the that should be what class, middle class value, right? So L13, and the Y list represents relative frequency, right? So well, I enter the relative frequency value in column named L12. So I just enter L12, and then you can choose any marker. Okay, so I just choose the I think just a square, and then press zoom. Okay, then press number 9. Okay, we got this, and then we see. We'll just press trace. Okay, let's see. So we see that for each one, the x value is 42 and the y value is 0.1. See, okay, so that's the more accurate. The graph is more accurate than this one. Okay, that was drawn by hand. Okay, so now it's question. The next question is this: what is the approximate shape of the distribution? So approximately, the shape of the graph is normal distribution. I mean bell shape. So we can see that approximately the data set is normal distribution. Okay, let's see. Let's back to the handout. Okay, so now next question is find the mean, median, mode, and mid-range. So find the range, standard deviation, and variance, and coefficient variation, and then find the 5-number summary and draw a box plot. Is a 69 outlier and 42 outlier. Let's see. Okay, let's figure out one by one. Okay. First one. Let's see. To figure out a median, let's figure out the mean and median and standard deviations, and then variance. Okay, using the calculator. So right here, and then we to figure out the mean and median, and then standard deviations, variance, and um, the Q1, Q1, Q2, Q3, right? It's a quartile. Okay, so let's figure out. You can do that you can figure out them by using calculator. So we press that. Okay, and then we go to the calculate tab. Okay, so now then we choose a one variable stack. Okay, so now we see that the list. Oh, excuse me. So we do we put the L C. Yeah, I entered the data value in L11, right? So I'll change this one to 11. 11. Okay, and then just leave a frequency list as empty. Okay, so we press calculate. So now the X bar, that's the sample mean. Okay, so which is 53.85. That's the sample that's the mean of the data value. Okay, and then the what see that S X, that's the sample standard deviation. Okay, and then the square of that value must be variance, because variance is the square of standard deviation. Okay, and then now next one is the minimum X value right there. Okay, but that's not problems. That's not the what we want, but we want a Q1. Median is nothing but Q2. Okay, Q1, Q2, Q3 right there, right? And okay, so Q1 is 51, Q2 is 50 or 54, or you can say median is 54, and then Q3 56. Okay, so now then give me a second. So now the median, I mean the mean, see that? Mean was the 53.85. Okay, and then standard deviation is 6.6. Let me round up. Okay, 7. Okay, and then the sample variance s square. That's the 6.67. When you find out the variance, don't take a square of this, okay? You have to take a square of the number before you round up, okay? So 6.66, okay? 708,332 square. So for me here, so now, yeah, let me do later, okay? Because I need to copy all numbers in the paper. So once you take a square of this one, and then you round up, keep in mind this, okay? So now next one, yeah, it's got the out of focus. Give me a second. All right, so I just took a square of that number. So it turns out that I got 44.45. So you don't have to round up. So 44.45. Okay, that's it. So that's the sample variance. Okay, and the Q1 is 51. You know the Q1. Q1 is what? 25%. 25%. The percentile, which means that 25%, 25% of the data values in a sample data set, their value is below 51. And the Q2 median, which means that 50% of the data values in the data set, their value is below 54. That's nothing but median, right? And the 56, Q3 is what? 75%. Okay? 75% of data values in the data set, their values are below 56. Okay, so this is nothing but so that number is nothing but P25. Okay, that number nothing but P50. Okay, there's nothing but P75. Okay, you know the P and P, the capital letter P means the percentile. Okay, so now next one, we want to find out mode and mid range, right? So the to find that mode, we have to sort the data first. Okay, so now then go to the oops, we go to the stack. Okay, and then sort a ascending A. We just choose a sort A or sort D. Okay, so sort A means sort the data set ascending order. Sort D means descending order. So let me do ascending order. Okay, L11. So let's see L, and then oh, 11. Okay. So now in this case, we got the error because I think the calculator doesn't recognize L11 as the name of the list, name of the list in the column list. Okay, so give me a second. So now to do that, so to sort data in ascending order, either ascending order or descending order, we go to the stack. Okay, and then choose sort A. Let me do ascending order, and then don't put the L11. You just press list. We go to the list. Okay, press second button and then press stack. Then we find the column name, okay, which store this the data, sample data values, which is 11, right? So 11, enter. Okay, you see that just you know the small the size of capital letter L right there. Okay, that's the meaning of the L, meaning of the that indicate that that one is the column name. Okay, and then enter close parenthesis and enter is done. Okay, now we call the just this call the L11, enter. Now you see you see that our data values are sorted ascending order, right? So now then we're gonna find the mode. Okay, So that's the way to you can uh, what when you find out the median by hand, you have to sort data, okay, like this. But actually, you don't have to do that because using the the one variable stack that function in the calculator, you can figure out the mean and median, right? So, but anyway, so see, then you can see the 51 is the appeared three times, right? So 51 must be a mode, okay, and then you see 54 is also appeared three times, so 54 must be a mode. So we got 51. Give me a second. Let me set mode is 51, 54, right? And then so 55 is also appeared three times. As you can see that 55 is appeared three times, so 55. Okay, so yeah, 56 appeared two times, but since the number that's the less than the 51 these values, so we don't count this one as mode. Okay, so I think that's it. So 51, 54, 55, these are mode. Okay, next one, let's find out the mid-range. Okay, so mid-range is a maximum data value plus minimum data value divided by 2. Okay, so we got max and minimum when you find out mean and in one variable stack. Okay, so we go to the variance. Sorry, we go to the stack, and then see we go to the stack, and then under calculate tab, click one variable stack. Okay, and then L just enter the L11 in the list, and then leave empty in the frequency. Then we got the see you see that here minimum is 42 and then maximum is 69, right? So this is the 42, or I mean 69 plus 42 divided by 2. Okay, 69. Okay, so that's the mid-range. Then what about the range? Don't confuse with the range and mid-range. The range is just a maximum minus minimum. Okay, so range is one of the measure of the variation. Okay, so standard deviation, variance, range. These are the tool to measure variation of the sample data set. And the mid range, that's the one of the tool to measure the uh, the center of the data sample data set. Okay, so don't be confused there. Okay, so yeah, so what's the maximum minus minimum? I mean, range is what, 69 minus 42, right? So which is the 27, right? Okay, so 27 right here, and this is the, give me a second, that's the what, 111, right? Divided by 2. So that's the 55.5, right? Oops. Okay, sorry. So now what are you gonna do? Next one, what's the next question? Give me a second. So we got median and mean and median, both mid range and range and standard deviation variance, and then coefficient of variation. Okay, so just give me a second. Let's see, coefficient variation. Coefficient of variation is this CV. It's called CV. Okay, so CV that is equal to S over X bar for the sample data set. Okay, for the times 100. Okay, coefficient variation must be percent, and then for population is what? Yes, it's almost same as this. The population standard deviation divided by population mean. Okay, so now that is equal to S is 6.67, right? Divided by X bar is in this case mean, that's the X bar, right? Simple mean. So 53.85. Okay. So now, so I got a point, just approximately yeah, approximately 0.1 2. Oh, times, I forgot the times 100. Sorry, that should be the 12.4%. Okay, approximately. Okay. So now then Next one is the box plot. So find the 5 number summary and draw a box plot. 5 number summary is what? Minimum. So see, 5 number. Oops. So 5 number summary is a minimum, and the Q1 and Q2 and the Q3 and the maximum. Minimum, sorry, minus 1.5 Q3 minus Q1. That is called the interquartile, right? This is called the interquartile. IQR. Okay, maximum plus 1.5 Q3 minus Q1. Okay, so these are called the 5 number summary. Okay, let's we already got most of them, right? Oh, by the way, I'm sorry. So the 5 number summary is just minimum. Okay, so it's minimum, Q1, Q2, Q3, and maximum. Okay, so then minimum minus 1.5 times IQR. That's the we use this one to figure out whether or not given data value, one single data value is outlier. So if a given data value is less than minimum minus 1.5 times IQR, then that value must be outlier. Or and a given data value is greater than the maximum plus 1.5 times IQR, then that data value must be outlier. Okay, so keep in mind this 5 number summary is just minimum, Q1, Q2, Q3, and maximum. This is the 5 number summary. Okay, but we already got all of them already, right? So minimum is what? 42. So give me a second. Minimum was 42, right? And then Q1 was 51, and then Q2 is 54, and the Q3 is 56, and then maximum is what? 69, right? Okay. So and then how to plot the box plot? So we go to the stack plot. Okay, second, the press y equals, and then we go to the plot on, and then you see that here. This that one. We choose the second one. The second row, second column, the type we choosing. Okay, and then X list it should be L11, right? So L11. The press zoom. Oh, we got this one. It's okay. We go to the stack plot and then press zoom. Yeah, jump number 9. Okay, and then trace. Now you see that. We got this. So since the that's the this is maximum, minimum, and that's a Q1, Q2, Q3. So we see that Q1 through the Q3, Q1 through Q3 is 50% the data values, all data values in the 50% of data value in the data set within that box. And then look at the positional box. It's kind of middle, right? So now we see that, oh, that means the 50% of data values are in that box, and the box is the located in the middle. Position is of the box is the middle between the minimum to maximum. Oh, then you can say that approximately the data is distribution of data is bell shape, which is normal distribution. Okay, so that's a box plot, and then next question is this: 69 is an outlier, 42 is an outlier. Yeah, so we figure out first. We need to figure out the minimum minus 1.5 times IQR, Q3 minus Q1. Okay, and then we need to figure out maximum plus 1.5, and then Q3 minus Q1. Okay, so then the minimum is 40. Oh, it's out of focus. Give me a second. So Q3 minus Q1 is what? The 56 minus 51, which is 5, right? So IQR is this one here, right? This is IQR, interquartile. Okay, so here IQR is 56 minus 51, which is 5, right? Okay, so in this case, minimum is 42, right? 42 minus 1.5 times 5, and then maximum is 69. plus 1.5 times 5. We just calculate them, okay? Yeah, I just calculate them. So I got 34.5 and then 76.5. Okay, so question is 69 an outlier? So no, 69 is not an outlier because 69 is not greater than 76.5. Okay, and then 42 is an outlier. No, 42 is not an outlier because 42 is not less than 34.5. Okay, yeah, I'm sorry about that. So the numbers what we got was wrong. Sorry. So it's not minimum. Okay, it's not maximum. Okay, should be this is Q1. That should be Q3. Okay, sorry. So this is completely wrong. So this is wrong. Okay, and sorry for making you confused. So the if outlier outlier means that the given data value is less than Q1 minus 1.5 IQR or Q3 greater than Q3 plus 1.5 times IQR. Okay, so Q1 is 51 and minus 1.5 times IQR, which is 5, right? That we're gonna get 40, we got the 43.5. And the Q3 plus 1.5 times IQR, which is that we're gonna get this 63.5. So the 69 is outlier. Yes, 69 is outlier because 69 is greater than 63.5. And the 42 is outlier. Yes, because 42 is less than 43.5. 43 times 5, okay, 0.5. So now, but there's easier way to figure out whether or what data values in the data set is outlier. So then in the calculator, using calculator. So here calculator, we go to the uh, stack plot, press second and stack plot. Then press we go to plot one, and then you see it. This one, not that one. This is the way. Oh, yeah, not that one. Well, this is we use that one to plot the box plot, right? We use the similar one, this one. Okay. Now and then we enter the data value L11. For me, I enter the data value in the L column L11. Okay, and then just frequency one, leave it one in the frequency. Okay, in the press zoom. Okay, and then 9. Then you can see that here the just press trace. Okay, then the 46 here, and then it's the 43 and then 42. So 46, that's the minimum value. I mean the minimum value within the Q1 minus 1.5 IQR and Q3 plus 1.5 times IQR. And then that definitely this is the Q1. Okay, for 51, this is Q2, Q3, and then you see that 62. Okay, that 62 is not the maximum value. No, it's not it's different from the regular box plot. Okay, 62 is a maximum value within the what Q1 minus 1.5 IQR and Q3 plus 1.5 times IQR. Okay, so now then those two values, see that 64 and the 69. See that 69 and 64. You see that these two dots represent what outliers, and then also see that below the 46, which is 43 and 42. See the two dots on the left side. These are outliers. It makes sense. You see that 42 and 43, and 42 is a minimum data value, right? The 42 and 43 is what less than 43.5. Yeah, it makes sense. So those two dots represent what outliers, and then these two dots also represent the outliers. So using that box plot, this kind of modified box plot, using that graph, we can figure out how many data are outliers easily, right? Okay, so the next question is, most US prisons are between what ages? That is, find the cutoff values for significant low and high age. So significantly low means that what two the x bar minus 2s, okay? So significantly low of the of value data value below the what below the less than the x bar minus 2 times the s. That is called the significant low, right? And then x bar plus 2s, if the data value is greater than x bar plus 2s, then we say that the data value is significantly high. So we need to figure out the cutoff value for significant low and high edges. So that's simply, we just calculate the x bar minus 2s, x bar plus 2s, okay? So right here, the x bar in this data set, x bar is 53.85, right? Then x bar minus 2s, that's going to be 53.85 minus 2 times. Simple standard deviation is 6.67, okay? And then x bar plus 2s is 53.85 plus 2 times 6.67, okay? So you calculate them. That's going to be the cutoff values. So I got the 40.51, okay, and then 67.19. So you can say that most US prisons are between the 40.51 and the 67.9 ages. We can say just 40 and 67. Okay, so because age is just the what should be integer. Okay, and the next question. So would 35 be a significant low age for prison? So 35, yes, because 35 is less than 40.51. The 60 be a significant high? No, because 60 is not greater than 67.19. Okay, so show why or why not with G-score. So let's find out G-score. So right here, what's the G-score? So G-score represent the number of the standard deviations. Okay, so here's G-score. So here's a mean. What's a G-score mean? 0, right? Because the because what mean what? So because G-score is a number of the represent the number of the standard deviation away from mean. Sorry, okay. So because mean is not away from the mean, so it's just number itself, right? Mean is itself. So the Z-score of the mean is 0. And then here's a 1 right there. If you got the Z-score 1, it means that that data value corresponding to Z-score 1, that number must be 1 standard deviation greater than the mean. Okay. So -1 means that what? If you got a -1 is Z-score of the certain data value, that data value means that data value what? These 1 times is the standard deviation less than mean. Okay. So the formula is this. Give me a second. Yep. So we got now we got now it's right. Okay. So now then the formula is this. Z-score is the x. This is given data value minus sample mean divided by standard deviation. Okay. So what we're gonna figure out is we're gonna figure out Z-score of 35. Okay. So here 35 minus x bar, which is the 53.85 over s is a 6.67, right? Z-score. Okay. Now the other one is what's about the Z-score of the 60? It's going to be 60 minus 53.85 divided by 6.67. Okay. So we just calculate that. So I got these numbers. Okay. So negative 2.83. It means that what? The G-score of the 35 is negative right here, negative 2.83. So what's negative to if the G-score is I mean certain value whose G-score is less than -2, then that value must be significantly low, right? So that's the cutoff value right here, -2, and then here's a 2 right here. It's cutoff value right there. So since negative 2.83, this is below -2. It means that what the 35 step value is below more than 2 times below the mean, more than 2 times the standard deviations. And then the z-score of 60 is 0.92, which means that the the depth value of 60 is the greater than mean, not more than 2 times standard deviation. It's just negative 0.2, negative 92 times standard deviation. That's the difference between the mean and the 60. Okay, this is significantly low, and then this is significantly high. Okay, keep in mind this. So that's all the problems, review problems. Okay, so next time I'm gonna cover chapter 4.